Let's take a look at lecture 2.1. All right, so we're looking at functions. Okay, so functions, we think of it as sort of like a machine. You input some item, normally we'd say x, you input it, your function will do something to it, and then you have an output, which we call f of x. So our input we call x, and our output we often call f of x. So the definition of a function. So the notation. The domain of f is the set A. So the domain of f equals A. Okay, so if the domain of f is all real numbers, we'd write dom f equals, and then all real numbers. The range of f is the set B, where we'd write reign f equals B. And the range of f is all the items such that x is an element of f of A. Okay, so any item you get from your domain, if you input it into your function, any of those outputs, that's what creates your range. So your range is all of the outputs that are created by your input values. All right, let's take a look at example number 1. We have a function here, f of x equals x squared plus 1, and we're asked to evaluate f of 2, f of negative 1, f of a, and f of a plus h. All right, let's begin. So, f of 2. Well, that says that take out x and replace it with 2. So wherever I see x in my function here, I'm going to be replacing it with 2. Well, I only see x right here where it's being squared. So I'll take 2 and I'll square it. And then I'll add 1. That's what my function tells me to do. Well, what's that? 2 squared is going to be 4 plus 1 is going to equal 5. So f of 2 equals 5. And box my answer. All right, let's do f of negative 1. Same thing, this is telling me, my function tells me whatever my input value is, you're going to square it and then add 1 to it. So my input value is negative 1. I'll square that and add 1 to it. That's going to equal 1 plus 1, which equals 2. So f of negative 1 equals 2. All right, now this is interesting. Now we have f of a, so there really is no actual numerical value being inputted. Instead, we're inputting a. So a is still my input, which means I'm going to take my input, square it, and add 1 to it. And that's it. F of a equals a squared plus 1. That's all we can do with that. Lastly, f of a plus h. Okay, so this time my input is this binomial a plus h. And remember, my function says, take my input and square it. Well, this whole value here is my input. So I'm going to take that, my input, and square it. And then add 1 to it. Okay, so we could leave it like that, or we could go ahead and FOIL it out. So it'd be a plus h times a plus h plus 1, which would be a squared plus 2ah plus h squared plus 1. So depending on how they ask you to leave your final answer, either one of these would be okay. All right, now let's look at this new function. This is a piecewise function. Very interesting. So what it has is there are 3 different options for my f of x value. I have this first option, then I have the second option, and then the third option. And it all depends on the input value I'm deciding to use. So if I'm trying to put in a number less than negative 2, I'd choose x plus 1. If I'm choosing to put in a number that's between negative 2 and 3, I'll use this part of the function. And if I'm choosing a value greater than or equal to 3, I'm going to use x squared minus 7. So it all depends on my input value, whatever is inside the parentheses. So let's take a look at the different items I'm going to be inputting. So first, I have f of negative 4. Well, my input is negative 4, so the question is, which one of these restrictions is it under? Is negative 4 greater than or equal to 3? No. Is negative 4 between negative 2 and 3? No. Is -4 less than -2? Yeah. So, since -4 fits this category here, we're going to go ahead and use x plus 1. So, that's going to equal, so let me say, we're going to use x plus 1, which means we take our input, -4, and we add 1 to it, which is going to be -3. So, f of -4 equals -3. All right, let's do f of 0. Well, where does 0 fit in? Try to take a moment and see if you can figure out where 0 fits in. Let's see. Is 0 less than -2? No. Is 0 between -2 and 3? Yes, it is. So we're going to use the function f of x equals -5. Okay, this is weird. Notice there's no variable by the -5. This is what we call a constant function. No matter what you choose to put in place of the x, no matter what you choose to input, your output will always be -5. It's constant. So, f of 0, well, it doesn't matter what we inputted, it's going to be -5. Okay, that's our constant function when it doesn't have a variable. Not too bad. Let's see, next is f of -2. What are we going to use? So, well, -2, oh wait, weird, -2 appears twice. So which one do I use? Well, this one says less than -2, and this one says greater than or equal to -2. So I'm going to choose this option because it's equal to -2, which means I'm going to go and use the constant function again. So f of -2 equals -5. One more to go. Let's see. Where would 3 fall under? Ooh, there's a 3 there, but we're not allowed to have it equal to 3. So here we have it. If f is greater than or equal to 3, and I'm inputting 3, so we're going to use this one, which means we're going to use x squared minus 7. So use f of x equals x squared minus 7. There we go. So I'm supposed to take my input value, square it, and subtract 7 from it. 3 squared is 9 minus 7, that's going to be 2. So f of 3 equals 2. And that is how the piecewise function works. So you check your input value and you figure out which piece your restriction applies to. Now let's take a look at the domain of function. The domain of a function. We've kind of already looked at this with just expressions, looking at when something is undefined. So we're going to go ahead and look at it again. So it's a bit of a refresher. But this time we're talking about it in function notation. So same thing, the main thing we want to look for is if your denominator would become undefined, so we look for fractions, and look to see if we have any possibility of a negative under an even root. So look out for, things to look for, would be radicals with an even number, so where n is even, and fractions. Okay, so let's start with A. Is there any chance that I could input a number for x and I'd end up with something undefined? No. There's no time when this would be undefined. And if you remember, this is also the equation of a line. And a line has a domain that is all real numbers. So there is no restrictions on a number times 2 minus 1. Or there are no restrictions on this linear equation. So the domain of this function is going to be all real numbers. Any number I plug in will work. There's no problems. So I'm going to go ahead and just write out negative infinity to positive infinity. Or you could do the all real numbers symbol. Either one would work. Unless they ask you to write your answer in a specific form. Which, notice, we weren't asked. So I'm probably just going to default to interval notation. Let's look at B. Aha, I see the square root there, so that keys me in. I know that square roots have problems. So what is the index number here? If we can't see it, remember it's a 2, which means that's even. So I know the values underneath my radical, I can't let that become a negative. So what I need is 2x minus 1 to be greater than, oh, can it be equal to 0? Is the square root of 0 defined? Yeah. 0 times 0 gives me 0. So I could let this equal 0. So we need 2x minus 1 to be greater than or equal to 0. Let's go ahead and solve that. So I get 2x is greater than or equal to 1, divide by 2, and I get x is greater than or equal to half. So I know that my domain, I need to have x greater than or equal to 1/2. Oh, I just realized I need to write this in interval notation. Remember how we said domain of f? I need to write dome of f equals negative infinity to positive infinity. Sorry, that was very much in the beginning, right here. That's how you're going to show your domain of your function. So that's my answer, dome of f equals negative infinity to positive infinity. So for this one, my domain, and this is my function g. My function is called g. So the domain of g is going to be, we're going to include a half and go all the way to infinity for all the values greater than a half. Okay. So remember, if we're given a function and we're trying to find the domain, we need to use that domain notation. Let's take a look at C. I see a fraction. I know problems occur with fractions because I cannot have 0 in the denominator. So I know that 2x minus 1 cannot be 0. I cannot let it equal 0, because if it did, then I'd have a 0 in the denominator, which means it'd be undefined. So I'm going to go ahead and solve this to find that problem number, the one that I need to take out of my domain. Okay, so x cannot equal a half, which means it can be any number but a half. So if you look at the whole number line, whenever we see if you look at a whole number line, let me draw an example. So if we look at the number line, when we see a half, we go, bloop, take you out. But everything else we can use. So how do I write that in interval notation? Well, the domain of, and this is y, is going to be negative infinity to a half. Don't include it. Union, begin again, and go to positive infinity. All right. Let's look at D. Ooh, this one's got a lot of problems going on. We've got a radical and we have a fraction. So I already see that we have two restrictions happening here. I know that the value under here, x minus 1, that needs to be greater than or equal to 0. So I need x minus 1 to be greater than or equal to 0. And I have one other restriction. I need this value to not equal 0 in the denominator. So x squared minus 4, that can't equal 0. Okay, so I'm going to go ahead and solve both of these. Add the 1 to both sides. Okay, so x needs to be greater than or equal to 1. And let's go ahead and solve this one. Ooh, square root property happening here. Remember our plus or minus sign when we do that. And x is going to equal plus or x cannot equal plus or minus 2. All right, so here we have an and statement. So I'm going to go ahead and just graph these two restrictions to get a better idea of what my final answer should look like. So I have 1 and negative 2 and positive 2. Okay, graphing the first one, I'll use green. I know that x is going to be greater than or equal to 1. Graphing this other one, I know that x can be anything except for -2 and +2. Okay, but this is an and statement, so I need to take where they agree. So friendship, if you think of friendship. So where they agree is right here, which we start at 1, go until 2, but we don't include 2, begin again at 2 or after 2, and go till infinity. And remember, this is my domain, so I need to indicate that it's my domain. Please show this in your work. And there we go. All right, I believe this is the last example. Okay, so there are 4 different ways you can represent a function. You can be given a verbal description. You can be given it algebraically. So algebraically would be like this. That's algebraically. You can be given it as a graph, for example, like a line, right? And you can be given it as a table. So if you had x, y, and then you had 1, 2, 3, 4, or something like that, or some other variation of a table. All right, so for example 4, we're told the function f, what does it do? Well, it multiplies the input x by 2, and then it subtracts 1 from the resulting product. So let's write this out. Well, the function f of x, it multiplies its input by 2. Well, multiplying by 2 looks like 2x. And then what happens? And then it takes 1 away from the resulting product. Well, what's the resulting product? The resulting product is 2x. So it'll take 1 away from 2x. Well, just take away 1. There we go. Subtract 1. And there we go. We have now written our function as an algebraic function. So if I wanted to write this function as a line, oh sorry, this is a line. If I wanted to represent it as a graph, I could go ahead and do it as a graph. So let's go ahead and graph this function for fun. Why not? Okay, here's my coordinate plane. And let's see, what are my values I can use? I'm going to go ahead and just plot this using the y-intercept and the slope. So my y-intercept is 0, -1. I pulled off the -1 there. And my slope is 2 over 1. So let's go ahead, do a rough little drawing of this. Okay, my y-intercept, 0, -1. Then my slope is go up 2, right 1. Up 2, right 1. And as usual, I try to plot 3 points. And I don't know where I put my ruler, so I'm going to go ahead and use my pen box. There we go. My line. What am I missing? My arrowheads. Yes, please remember to put your arrowheads. Those are worth points. All right, and there we go. That's another way I could represent my function. So I've got the verbal, I've got the algebra, I've got the graph, and then you could also do a table. And that is it for 2.1. Here's your written homework due by the end of the week. Please email me if you have any questions.